Hi, this is Herb Chabot of the Dr. Vax channel. If you want to communicate effectively in a foreign country, I happen to live in the United States. If I go to France and I want to be able to communicate fully with folks in France, I need to speak French. Germany, German, Israel, Hebrew, Saudi Arabia, Arabic. So likewise, if I want to be really good at using a 3D printer, I need to understand something about the language of 3D printers, the language that's used to communicate between a computer and a 3D printer. That language is called GCode. And stay tuned today, and we're going to learn something new. We're going to learn about GCode that will help you initially install new printers into a slicer, the program that's used to convert between a three-dimensional object and an object ready to be printed. It'll help you fine-tune your prints. It'll help you understand better the parameters in a slicer. So stay tuned. Let's learn something together. GCode, geometric code, is not at all new. It was developed in the 1950s at MIT, and it was developed for use with numeric-controlled machines. Numeric-controlled machines are machines where some type of automation is used to control a manufacturing machine. Initially, you would put instructions on a printed card, a punched card that would go into the machine with the instructions. Then they switched to magnetic tapes. Nowadays, most numeric control machines are actually computer numeric controlled machines because they're controlled by computers. A 3D printer is a form of a numeric controlled machine, and it uses GCode or geometric code, a variation very similar to the original GCode developed in the 1950s. One of the nice things about the GCode that's used by most FDM-style 3D printers is it's human readable. It's not in binary bits and bytes, it's in text. It's something you can read and learn to understand. And today, we're going to learn how to understand the variation of GCode that was created for RepRap 3D printers. Those are the style of FDM 3D printers that most of us use at home and many of us use in the office. Let's look at this picture together as a bit of background. In this picture, you'll see a three-dimensional object on the left. That three-dimensional object is created by a computer-aided design program. You could use something as simple as Tinkercad. You could use Fusion 360. You could use much more sophisticated programs. But you create a three-dimensional object. 3D printers can't actually print three-dimensional objects. 3D printers are really very simple machines. They print a layer at a time. It's almost like printing on a piece of paper and then putting a new piece of paper in and printing another layer. Except they stack those pieces of paper, those layers, one on top of the other to create a three-dimensional object. So you need to take your three-dimensional shape and you need to convert it into a series of layers. That function is done by a slicer, and the format used by many FDM-style 3D printers, filament-based 3D printers, is GCode. So on the left, you see a three-dimensional object. In the middle, you have a slicer creating individual layers. And on the right, you'll see that your printer is just drawing lines and shapes, a layer at a time. Now, to understand GCode, we also need to go back to a bit of geometry. And remember that a three-dimensional printer has an x-axis, a y-axis, and a z-axis. Now, the starting point could be in the very center. In this case, this is a monoprice Delta Mini printer. Now, I'm not really a big fan of the Delta Mini. I don't think it's a very reliable or easy to use printer. It's very, very inexpensive, but it's a blast to watch. So we're going to use it today for some examples just because it's fun to watch. In the case of this printer, the origin, or the 0, 0, 0 point, 0, 0, 0, is in the center. On many FDM-style, Cartesian-style 3D printers, the origin is the bottom left corner. So when you're telling the printer to go to position 1 on the x-axis, 1 on the y-axis, and 1 on the z-axis, you need to know relative to the origin. Okay, let's go to the screen now and take a look at some actual G-code. The first command, G28, is a command that says to the printer, move the print nozzle to the origin, to 0, 0, 0. The second command, G1, says move to X location 10, Y location 0, Z location 0. So that's basically going to draw a line that's 10 over on the x-axis and 0 on the y-axis. So right along the x-axis, it's going to move 10 positions over. At the z-axis, it's not going to move up at all. And it's going to do it at 300 millimeters per minute. So F300 means move at 300 millimeters per minute. And over that distance, it's going to extrude 0.04 millimeters of filament. So you've just seen all of the magic of G-code. You're at a given point, you tell the printer to move to another point and extrude some plastic. If you extrude more plastic, your line is going to be thicker and wider. If you extrude less plastic, your line will potentially be thinner. You're going to do that over and over again. Then you're going to move up your z-axis. So for the next line, maybe instead of Z0, you're going to be at Z.20. Now I want to actually correct something I said here. The first layer is really not extruded at 0 because there'd be no place for the filament to go. So if you have a 0.20 layer height, that first layer will start at 0.20. Now let's look at the various classes of commands. Here's some simple commands. G0 and G1 are commands to make a movement to move the printhead. G0 says, move there as fast as you can. G1 says that you should move there linearly. G1 is optimized for precision. G0, depending on your firmware, is optimized for speed. In many FDM printers, there's no difference between a G0 and a G1. Most of the G-code I see produced from slicers uses a G1 for everything. G29, and we're going to show you how that works in a minute, says to your printer, if you have an AutoBed leveling system, probe the bed. Calculate the height at each position on the bed. G28 says move to the home position, 0, 0, 0, or in some cases, X and Y, 0, 0, but Z wherever you're currently at. There are M commands. M commands really talk to the firmware versus the printhead. So M117 says put a message on the LCD, if there's an LCD in the printer. G90, 91, and 92 are used to set the printer into either absolute or relative mode, and then set an initial position, a starting point. So as an example, relative mode says when I give you a movement, add that amount of movement to the current position. Absolute mode says that go to this point in this three-dimensional space. Depending on your slicer and your printer, you could be using either. Slicers originally only generally supported one or the other. Many slicers support both today. M503, in general, the M500 series of commands, 500, 501, 502, 503, they control the defaults, the parameters stored in your printer. And then the M104 and the M140 commands are examples of commands that control the temperature of the extruder, the hot end, and the temperature of the print bed. Okay, now let's look at some G-code together and walk through it to get an idea. This is G-code that's sent to a printer by the slicer before every print. And this is typical of the types of things that are done. So the M117 command at the beginning puts a message on the LCD panel. Then it resets the extruder's distance to 0 so that the printer, all future print commands will be relative to that 0. It homes all the axes. It resets the extruder again, that's sort of redundant. And then it's going to move the z-axis up a little bit at 3,000 millimeters per minute. Now, why is it going to do that? Well, it's going to move the print head around in order to prime the nozzle. Priming the nozzle is where you extrude some filament away from your print so that you can make sure it's flowing smoothly. And we don't want to scratch the print bed when we're moving a nozzle around. So G1 says move the nozzle to 1 millimeter above the print bed. And then the next G1 says go basically to the origin. That would be just a little bit off the bottom right-hand corner if you're on a Cartesian printer, and this was for a Cartesian printer. And then move to Y20 at a height of 0.3 of a millimeter above the print bed. And that's the start position for a line. Then you'll see on the next G1 command, there's an E15 that says extrude 15 millimeters of filament. So the next move is going to move the print head along the y-axis another 80 millimeters from 20 to 100. Also 0.3 millimeters above the print head, that would be like a 0.3 millimeter layer height, extruding 15 millimeters of filament. That's going to draw a line. So that's what's called the waistline or the index line. And it's used to make sure, once again, the filament is moving. We move a little bit over, we draw a second line, then we reset the extruder to 0 so the slicer has a starting point. We move the z-axis up a little bit, and we're ready for our print. Now, if you really want to learn about G-code, the best way is to connect a printer either over Wi-Fi or directly to your computer and send it some commands to see what happens. So we're going to show you both ways. First, I have this printer plugged into a USB port on this computer, and I'm going to run a program called MatterControl by MatterHackers. MatterControl is a very nice terminal interface. It has one limitation I'm going to point out, which is why I'm going to use another program for our examples. So let me switch here to MatterControl. I'm already connected to this printer. And if we go to our terminal panel here, you'll see these numbers scrolling up the screen. Well, by default, MatterControl is sending a message to the printer, a G-code. And the G-code it's sending, we can actually look at that. So we can say, show us that, is an M105. See the M105s here? It's sending an M105 that says to the printer about once a second, tell me the temperature of the extruder and the bed and how many extruders you have on this printer. Well, we're going to turn off seeing the temperature requests, and we're going to scroll down a little bit, and we can see that we have the ability here to enter a command. So I'm going to enter an M503. M503 is a command that says to the printer, tell me what your stored values are. I'm going to say send. Now, because this is continuing to scroll, I have to actually sort of freeze this. It's a little tricky to do here. You have to get to the spot you want. And then we'll see that I sent the M503 command. And then here are the results that came back from the printer. Now this is connected to a Delta printer, so the origin is in the middle. And so there's some special values because it's a Delta printer. Because of the scrolling temperature, and there might be a way, but I haven't found out how to turn that off on MatterControl, we're going to actually connect this printer a different way. We're going to connect it to an Octoprint box. Octoprint is a program that runs on a Raspberry Pi. It can run on other computers also. This is running on a Raspberry Pi. It's about a $60 computer with the case and the power supply, maybe $65. That is a really easy way to add Wi-Fi to any printer. So I'm going to take and disconnect the printer here. I'm actually going to turn it off for a moment here. I'm going to connect my Octoprint box to this printer. And now we will power it back on. I'll close this window and I'm going to go to my Octoprint window and say connect. So now we're connected to this printer over Octoprint, and Octoprint also has a terminal window. And we can see here in the terminal window that it connected to the Monoprice printer. Monoprice's printer, this particular printer, is made by a company called Mayan, which you can see here in the firmware connection. There's a very nice feature here to suppress temperature messages, and that'll make it much easier to see things. So if we did the M503 command again, and we did a send, we'll see here are all our values, and we can easily scroll through and take a look at those. Now, let's actually make this printer move. We're going to start with a G28 command. A G28 command will home the printhead. On this printer, it will move it to sort of this center top position. Isn't this fun to watch, this printer? So we just did that. If there had been a G28 command on an SD card that was loaded into this printer and we said print, that's exactly what would happen. Now we're going to send a command to the printer to check if the print bed is level. On this printer, it does it in a very interesting way. You might be able to hear these clicks. It actually causes the print head to touch the print bed and trigger a micro switch, so it knows the distance where it hits in multiple places on the printer. So the command for that is G29, and then you do with this printer have to tell it what the standard height difference is between the response of the switch and the actual print head. I'm going to tell it's 0.04 millimeters. So let's go ahead and watch this do the AutoBed level. So it's going to go down, go over to the corners, 3 locations I believe, I remember, and it's going to check those 3 locations. So when you see your printer do an AutoBed level check at the beginning of a print, that's because your GCode file has a G29 command in it. And we can see here are the offsets for the 3 positions from those tests. Because in each position it showed us what the offsets were. Now, let's say we want to move to a particular position. Well, first we're going to do a G90 that says put this printer in absolute mode. So I can tell it exactly where to go. And we see here that that completed correctly. Then I can say G1, move the printer to X0, Y10 at a speed of 3,000 millimeters per minute. Let's go. Now, it didn't move it down at all. That's because I didn't give it a Z height. I can say set the Z height to Z 0.20. So 0.2 millimeters above the print bed because I'd be using a 0.2 millimeter print layer height. And now we're all ready that if I go ahead and do a Z1, and let's now move it to Y100, same X position, and I'll set an E 0.10, that would say now draw a line from where it's currently out at to the Y100 position, extruding 0.10 millimeters of filament. Now there's no filament loaded in this printer, but there's not a filament sensor on this printer either, so it's not going to know it. This command will still work fine. Whoops. What happened there? Well, this printer only has a 120 millimeter print bed, and so it started in the middle, so I only had 60 to go. I moved it too far. Okay, I've powered cycled the printer, I've re-leveled the print bed, I re-honed it to the center, and now we're going to try the command again, and this time I won't drive the print head off the surface. So we're going to do a G1 Y20 this time. We'll make it Y30, extruding 0.5 millimeters of filament. And that's exactly how it would work. So theoretically, you could sit here at the computer and you could draw things on your 3D printer. It's very much like Turtle Graphic. And in fact, that might be an interesting way to teach children a bit of geometry. Well, folks, I hope you learned something today. I did. Don't try to send the print head further than your print bed. Fortunately, this is a very inexpensive printer. It didn't break anyways, but you can do damage if you're not careful. And more importantly, I hope you learned a little bit about GCode, what it is, how it's used to control the printer. And now when you look in your slicer and you see the GCode before a print and the GCode after a print, you can interpret it yourself. If you want to learn more about GCode, just go into Google and type GCode, and you'll see lots of sources for it. If you type Marlin GCode, you'll see the GCode for most consumer-grade, home-based 3D printers. Thanks again. Please give me a thumbs up if you found this interesting, useful. Share this video with everyone you know. Recommend it to folks. And subscribe to the channel. Don't forget to hit the bell so you'll learn about new videos as they're published. And leave me comments so we can continue to learn things together.